So there are just a few important glasswares that are used in volumetric analysis. And in titration, a volumetric flask is used to prepare a solution of known concentration, which is your titrant. And to use the titrant in titration, you first prepare the titrant by dissolving a precisely weighed amount of standard chemical into the volumetric flask to create this titrant. So this is actually similar with what we performed in the laboratory on how to prepare solutions. So basically, if you have for example, you're going to prepare a sodium hydroxide solution. So of course, you need your weighing boat or a beaker to actually get the weight of your solid substance, or in this case, since you're preparing a titrant, so you're going to get your amount of sodium hydroxide. And then, basically, i-dissolve lang siya sa deionized. Take note, you need to use deionized water because in titration, the presence of contaminants and carbon dioxide in your water can actually affect the quantities in terms of your calculation. So it can actually affect the concentration value of your solution. So that's why we use the ionized water in analytical methods. So after you dissolve it, you just do number 3, which is to transfer it to a volumetric flask. So for you to be able to do a quantitative transfer, you can use a funnel. So it depends on you if you're an expert on transferring solutions, so you can also use the glass rod or the steering rod. So here, in order to quantitatively transfer everything, you have dissolved in the volumetric flask, so you can also use your wash bottle to rinse the beaker where you dissolve your solid substance. So transfer lang siya and make sure that everything is transferred there. But don't worry, you will be able to know the concentration of this after you standardize this with a primary standard. And recall, how do you check again the volume of your solution when you're preparing it in the volumetric flask? So we refer to it as when we have a clear or colored solution. So if you have a clear solution, you need to look at the bottom meniscus and it needs to touch the scratch mark or the mark on the volumetric flask in order for you to know that you are able to dilute your solution up to the mark. And now your titrant is ready for calibration. Another or one of the most important glasswares in titration is your burette, and it depends on you if you want to spell it American English or British English. And a burette, it is crucial for titration because it allows for the precise and accurate dispensing, or you add your what's this titrant drop by drop, and it actually enables accurate measurement of the volume needed to reach the end point of the reaction. So in the lab, the commonly used burette is the glass burette, but nowadays, since it's more convenient, they use the digital burette, and this can also be calibrated. By the way, your glasswares and digital instruments, you need to actually get it calibrated. Or what that means is, if, for example, you want to know if 50 ml is accurately 50 ml, so you need to calibrate it in order to know if it's 50 ml or it is actually lower than 50 or higher than 50. That's what calibration means. And we also have electronic burette if you're also dealing with ions in your solution or you want to check if there are charges involved. And for your burette, so the burette's marking allows us for the precise measurement of the volume of the titrant delivered, so often 100 place. So you actually need to check it at eye level or reading the meniscus at eye level. So there should be no bubbles and the temperature should be consistent. These are very important to make your measurements or readings accurate. The next one is the pipette. So your pipette that is used in titration to accurately and precisely measure the transfer of a fixed volume of a solution. So this one, when you're preparing your sample and you're transferring your sample into the Erlenmeyer flask, so typically the analyte is in that sample. So you are going to transfer it in the flask before the titration or you begin the titration. And aside from that, we can also use a glass pipette or a dropper to add your indicator drop by drop. So that's the use of your pipette. And if you're using a titrant that is an acid, so you can also use the glass pipette to prepare your titrant in that case. So since we are already aware of what are the different terminologies and glasswares that we can use for titration, so now we are almost ready for titration. So after you prepare the sample in the titrant is placed in the burette, which is rinsed with the titrant, or you actually need to put it first and wash it, or you dispense it here. So this can actually be opened and closed, or what we call hold and release. And this is pretty much drop by drop or a very slow, steady pace, or it can be very fast. So you need to be able to control your what's this? The opening and closing of this burette. So after washing, so you need to ensure that there are no air bubbles and the initial volume is recorded. So usually we fill this up to 0 because at this first mark above the burette, so it's actually at 0. So you need to get the initial volume, and after you do the titration, you get the final reading. So the titrant is slowly added from the burette to the analyte. So your analyte is in this flask because you already prepared it here. And while the flask is swirled, so during the titration, by the way, you need to stir this or shake it if you don't have a automatic stirrer, so you can just shake it or swirl, we call this swirl, until the indicator shows a persistent color change at the endpoint. So the endpoint or the color change will now indicate the completion of the reaction. So you need to stop this or close it and get the final reading. So that's actually an overview of how you do the titration process.